Good morning. I am Reggie, Associate Professor, Department of ECE, Rogni College of Engineering and Technology. Electromagnetic waves. So, transverse electromagnetic waves. Today we are going to discuss. Consider an electric field is totally along the x-axis. E transverse equal to Ey is equal to 0, and the magnetic field along the y-axis Hs is equal to Hy is equal to 0. Both the electric and magnetic field component are transverse to the direction of propagation on Z. So the wave is said to be transverse electromagnetic wave or principal wave. TEM wave is a special case of transverse magnetic wave in which electric field E is set along the direction of propagation. The condition on E set is obtained if M is made to 0 in TZ wave. TEM wave is always called as principal wave. Consider the wave which is in the direction X, Y and Z axis. The TEM wave in which M equal to 0, the field equation for TEM, Hy is equal to C4 cos of M pi by A x e power minus j beta Z. Ex is equal to beta by omega epsilon C4 cos of M pi by A x e power minus j beta Z. Ey is equal to j M pi omega summation A C4 cos of M pi by A x e power minus j beta Z. Putting M equal to 0 in the above equation of TM wave, the field equation of TM waves are obtained. Hy is equal to C4 e power minus j beta Z. Ex is equal to beta by omega epsilon C4 e power minus j beta Z. Ey equal to 0. These fields are not only transverse but also constant in amplitude across the cross-sectional normal to the direction of propagation. Characteristics of TEM wave. For M equal to 0, the dielectric is here. Propagation constant gamma equal to M pi by A the whole square minus omega square mu naught epsilon naught. Gamma is equal to minus omega square mu naught epsilon naught. Gamma equal to j omega root of mu naught epsilon naught. Gamma equal to alpha plus j beta. So gamma equal to j omega square root of mu naught epsilon naught. So equating the real and imaginary part, we will get beta is equal to omega root of mu naught epsilon naught. Guided wavelength lambda g is equal to 2 pi by beta, lambda g equal to 2 pi by 2 omega root of omega naught epsilon naught. V naught equal to 1 by root omega naught epsilon naught. So lambda g equal to 2 pi v naught by 2 pi f, where lambda is called wavelength of free space. Velocity of propagation omega by beta, omega by omega root of mu naught epsilon naught, which is equal to 1 by root of mu naught epsilon naught. So velocity of light is equal to 3 into 10 power 8 meter per second. From this, cutoff frequency Fc is equal to m by 2a root of mu naught epsilon naught. For m equal to 0, Fc is equal to 0, cutoff frequency of TEM wave is 0, indicating all the frequency down to 0 can propagate along the guide. The ratio of the amplitude to E to H between plane is defined as characteristic wave impedance. So Ex by Hy equal to beta by omega epsilon, omega root mu naught epsilon naught by omega epsilon naught. So which is equal to root of mu naught by epsilon naught, which is equal to eta. Eta is called the intrinsic semiconductor of the dielectric media existing between the plane. So here Ex is equal to eta Hy. The total power propagating in Z direction is calculated using the Poynting vector gamma equal to double integral E cross H dx dy. So power which is equal to x limit minus a by 2 plus a by 2 and limit y is equal to 0 to 1 Ex by root 2 into Hy by root 2 dx for 1 meter along the direction of propagation. So the Poynting vector states that P is equal to 1 by 2 Ex Hy x minus a by 2 plus a by 2 1 by 2. So P is equal to 1 by Ex Hy a. So Ex is equal to eta Hy, P is equal to 1 by 2 eta Hy, Hy into a. So P is equal to 1 by 2 eta